Hello everyone, my name is Sayogo Utomo, and today we're going to talk about discrete uniform distribution and continuous uniform distribution. So, let's get into it. So, for the first one, we're going to talk about discrete uniform distribution. It is an event for each given result has an equal probability to become the output. And as the example, when we're rolling a fair die, if you roll a 6-sided die, the probability of getting one of each number from number 1 to number 6 is equal for each number. And as we can see in the pie diagram, for each number from number 1 to number 6 has the same value area. And to calculate the probability, we will use this formula. Fx will be equal to 1 out of x, and since the die has 6-sided, so the x will be 6, and for each side will be 1 out of 6 probability to become the output. The next one is mean in discrete uniform distribution. The mean of all rows that happen on an event will be calculated by the sum of the lowest number that can appear and the highest number that can appear on the event. The more the times, the more the result of manually calculated mean is closer to the means formula. And the formula will be p plus q divided by 2, and since 1 is the lowest plus 6 is the highest number on die, divided by 2 will be 3.5. And the next one will be variance. It can be calculated by this formula, and q is the highest number that can appear on the event, and p is the lowest number that can appear on the event, and while the n is the probability that can appear on the event. So when we're using the first formula, it is q minus p plus 1 square minus 1 divided by 12, and the result will be 2.917. And for the second formula, we will have n minus 1 times n plus 1 divided by 12, and we will have the same result as 2.917. And for the standard deviation, we can search it by square rooting the result of the variance itself, so we will have 1.482 as the result. Next, we will have continuous uniform distribution. Continuous uniform distribution basically is a close thing with discrete uniform distribution. The difference is continuous uniform distribution has measured values, and discrete uniform distribution has finite number. For example, continuous uniform distribution can be used by calculating the probability of crashing in range time. And the example itself is how much time needed to reach school by bicycle. And this is the example itself. A student going to school by bicycle every day. The time taken to reach school is uniformly distributed between 10 minutes to 30 minutes. Then we can see in this diagram, fx will be the height and L will be the length. So we will search the area of the red colored area, and as the length will be equal to 13 minus 15 will be 15, and the fx is 1 out of 30 minus 10, which will be result as 0.05. Then the probability will be 0.05 times 15, and will be equal to 0.75. And what if we search for the finite number? The example is, what's the probability the time needed for a student to reach school is in 14 minutes. You can see the diagram. It is a line, so the length of the area will be 0 because there is no range line, and the fx as the height will be same is 0.05, and the px is 0.05 times 0, which will be equal to 0. And what if the probability student needed time between 40 to minutes? As we can see here, it is have no height but have the length itself. So the px will be fx times l, the x will be 0, and the length will be 10. It is 0 times 10, and the px will be 0. And the last one is the implementation in daily life. Discrete uniform distribution can be used to measure stuff that have the same distribution of some products. For example, if we're selling a few types of cereal and they have the same probability to being bought by someone, and we can decide that the stock is all the same for each product. And for the continuous uniform distribution, we can predict the probability of time consumed for going to work, or to measure the probability of defect product that can be produced by a machine. So that's all from me. Before to end this video, I will link all of the sources on the description so you guys can check it out if you want to learn better. And thank you for watching this video. See you guys next time.